किस्मत की लकीरें भी अपना रास्ता बदल लेंगी, तू एक दफा मेहनत करके तो देख। इसी विचार से आज का वीडियो स्टार्ट करते हैं। आज का वीडियो है मोल कंसेप्ट पे। स्टूडेंट्स एंड एस्पिरेंट्स, आई होप आप लोगों की पढ़ाई बढ़िया चल रही होगी और मैं उम्मीद करता हूं कि आपने इसके पहले वाली वीडियो भी देख ली है और उसे अच्छे से समझ ली है। तो आज का टॉपिक है मोल कंसेप्ट। आज हम दो चीजों के बारे में पढ़ेंगे। फर्स्ट ऑफ ऑल, व्हाट इज मोल कंसेप्ट, एंड मोस्ट इंपॉर्टेंटली व्हाई डू वी नीड मोल कंसेप्ट, एंड सेकंड है कुछ न्यूमेरिकल्स। तो लेट्स begin with the basic definition of mole. One mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 gram of carbon 12. The important thing to note here is 12 gram and carbon 12. The reason is carbon has multiple isotopes, namely C13 and C14, and that is not applicable here, only C12. So that is 1 mole. That is the definition of 1 mole. Secondly, 1 mole, the number is denoted by the symbol Na or N0. That is also called Avogadro constant. That was invented by a scientist named Avogadro, and this number has been honored in his name and is called Avogadro constant. Now let us see what that number actually is. So there are three things in the first equation which we want to see. First is carbon 12, that is the first thing. Second is as many atoms, this denotes a count, and in 12 grams of carbon 12. Okay, so what we can do is, first of all, let's get the mass of a single carbon 12 atom that has been found by mass spectrometer, and that came out to be this number, 1.992648 into 10 raised to minus 23 grams. This is the mass of one carbon atom. Hence 12 grams of carbon atoms will have 12 divided by the mass. That comes out to be 6.022 into 10 raised to 23 atoms per mole. So this number 6.022 into 10 raised to 23 is the Avogadro constant, or Na. Whenever we say 1 mole of any element, any atom of an element, any molecule of an element, what we want to say is 6.022 into 10 raised to 23 quantities of that atom's element. Let's say I am saying I want 1 mole of hydrogen atoms. So 1 mole of H atoms is equals to Na quantity of hydrogen atoms. When someone says I want 1 mole of oxygen, 1 mole of O2, that means Na quantity of O2 molecules. So mole can be related to atoms, mole can be related to molecules, mole can be related to anything. You can also say 1 mole of pens, 1 mole of mobiles, or any other thing which you have. 1 mole simply means 6.022 into 10 raised to 23 quantities of that object. Now before we move further in this topic, let's talk about another aspect, which is AMU, or atomic mass unit. So the definition of atomic mass unit is exactly 1/12 the mass of a carbon 12 atom. So carbon atom का mass हमने अभी देखा था, which was 1.992648 into 10 raised to minus 23 grams, and that we need to divide by 12, and we arrive at this number 1.66056 into 10 raised to minus 24 grams. This means 1 AMU or 1 U, where U stands for unified mass. So this is the unit which we use to measure the mass at atomic levels. Let's take example of hydrogen atom. So mass of one hydrogen atom, a single hydrogen atom, is 1.6736 into 10 raised to minus 24 grams. 1 AMU is 1.66056 into 10 raised to minus 24 grams. Hence, weight of one hydrogen atom in terms of AMU. So if you divide, it comes out to be 1.008 AMU, or almost equals to 1 AMU. So let's understand first, what does AMU help in? So AMU helps in understanding the reactions at an atomic level. For example, you cannot say, or it is very hard to say that I want to react 1.6736 into 10 raised to minus 24 grams of hydrogen atom with another element. ये करना और ये कहना बहुत मुश्किल है हर बार. That is why we use something called AMU. You can simply say I want to utilize 1 AMU of hydrogen. This is much easier, right? 1 AMU of hydrogen with X AMU of another product. So AMU helps in simplification of reactions at an atomic level. Whenever you want to do it, it is much easier to talk in terms of AMU. Let's take an example of a equation, chemical equation. C plus O2 gives CO2. Now let's consider this example in terms of grams. So one atom of carbon weighs 1.99 into 10 raised to minus 23 grams, and one molecule of oxygen weighs 5.314 into 10 raised to minus 23 grams. The total will be 7.3 into 10 raised to minus 23 grams. Now expressing in this format is very hard. Instead, you can simply say 12 AMU or units of carbon, 32 units, because one oxygen atom is of 16 AMU or 16 units. The total will be, of course, 44 units. So expressing in this format is far more easier. Now let's circle back to the original concept, which is mole concept. We have learned what is mole, what's the quantity of mole, what's the value of mole. We have also learned that 1 mole of anything is basically Na number of those entities. एक मोल हाइड्रोजन मतलब हाइड्रोजन एटम मतलब 6.022 into 10 raised to 23 हाइड्रोजन एटम्स. इन ऑक्सीजन मॉलिक्यूल्स में Na number of oxygen molecules. But the question is why do we need it? This is the first question. And second question is, even if we have it, why have we fixated on this number? Why it is Na? Why not some other number? I'm pretty sure only the rankers will actually understand why do we have this number. Normal students को तो बस वो पढ़ के आगे बढ़ जाते हैं, उन्हें कोई मतलब नहीं है, वो बस रट लिया उन्होंने, समझ लिया उन्होंने, बट उन्हें एक्चुअली में आइडिया नहीं होता कि ये यूज होता क्यों है. The main use of mole concept is to simplify things at a practical level. I will explain you how. Let us understand the problem using sugar. At your home, what do you have? You have 1 kg sugar packets usually. Okay. अभी sugar packets है. What do? You use 1 spoon of sugar for your tea. 1 spoon sugar का weight होगा approximately 10 grams. Right? This is a rough estimation, of course. To explain, इसका मतलब है 1 kg sugar में roughly 100 spoons of sugar available है. But the question is, whenever you go to a shopkeeper, do you say, I want 100 spoons of sugar? No, you don't, because that is a very inconvenient way of saying I want 1 kg of sugar. It is very easy to say I want 1 kg of sugar. 100 spoons of sugar बोलने का कोई सेंस नहीं बनता. In fact, shopkeepers themselves, they buy in packets of 100. मतलब they buy, so 100 packets will have roughly 10,000 spoons of sugar. But whenever they go to a dealer, they don't say ki, hey dealer, I want 10,000 spoons of sugar. They don't say such things. They instead say, I want 100 packets of sugar. When from home to shopkeeper, when you go to the shopkeeper, you say, I want 1 packet of sugar, which is of 1 kg. When you go to your home, you say, I want to add 1 spoon of sugar. You don't say, hey please add 10 grams of sugar to my tea. ऐसा नहीं बोलते हम. 10 ग्राम चीनी ऐड करने कोई नहीं कहता. कहते हैं भाई 1 स्पून चीनी ऐड कर दो हमारी टी में. सो एज यू कैन सी, जो हर एक लेवल पे देयर इज अ डिफरेंट कन्वीनियंट वे ऑफ एक्सप्रेसिंग द मास. Same thing happens in chemical reactions also. In this equation, we see 1.99 into 10 raised to minus 23 gram of 1 carbon atom reacts with 1 molecule of oxygen, जिसमें 2 oxygen atoms हैं. उसका मास है 5.314 into 10 raised to minus 23 grams to create 1 molecule of carbon dioxide, जिसका मास है 7.3 into 10 raised to minus 23 grams. इसको बोलते हुए समझ में आ रहा है, अगर इस तरीके से हम कैलकुलेशंस करेंगे तो नहीं होने वाला कुछ भी, बिकॉज हियर वी आर डीलिंग एट एन एटॉमिक लेवल. यहाँ पे हम वन एटम से कैलकुलेट कर रहे हैं, राइट. लेट्स से अगर हमारे पास ग्राम्स में है, इवन इफ यू से ग्राम्स, तो हमें इस इक्वेशन को चेंज करना पड़ेगा वेयर यू आर डीलिंग इन सिंगल एटम्स. लेट्स से यू वांट टू टेक 1 ग्राम ऑफ कार्बन. दैट मीन्स that is roughly equivalent to 5 into 10 raised to 22 atoms, which will be the coefficient over here. वैसे ही ऑक्सीजन पे coefficient आएगा and CO2 पे. Even that is very cumbersome. We need a better way to utilize this equation while using weights in grams. And यहाँ पर ही the Avogadro number or the concept of mole comes into picture. Let me show you how. First of all, let's understand 1 or 2 things. This is more from a numerical perspective and a overall understanding of the picture, and let's not take it word to word. The units in AMU. So as you know, hydrogen we had found it was roughly equal to 1 AMU. So 1 AMU almost corresponds to the mass of 1 proton or 1 neutron, because दोनों का mass almost same है. So as you know, in carbon you have 6 protons and 6 neutrons. In carbon 12, so its mass is its mass number was 12. Its weight in AMU is of course 12. For O2 it is 8 and 8, मतलब 8 protons and 8 neutrons, total 16. So and since there are 2 atoms of oxygen, it is total 32. If you consider AMU of 1 oxygen atom, it will be 16U actually. For O2 it becomes 32U. So the number in AMU roughly tells you the mass number of that particular entity. Now let's use Na. Let's multiply this the weight of single atom of carbon. Let's say 1 atom of carbon. There is 1 molecule of O2 and 1 molecule of CO2. We are assuming that we are multiplying all of these weights by the number Na, or 6.022 into 10 raised to 23. The moment you multiply by this number, 1 atom converts to 1 mole, right? 1 mole of carbon atoms plus 1 mole of O2 molecule gives 1 mole of CO2 molecule. Because you have multiplied all of these entities by Na, from one atom they have converted to 1 mole of carbon atoms. From 1 molecule of oxygen it has converted to 1 mole of oxygen molecules, and from 1 molecule of carbon dioxide it has converted to 1 mole of carbon dioxide. Now let us look at what happens to this AMU. If you do the complete calculation, this will becomes 12 gram of carbon reacts with 32 grams of oxygen to give 44 grams of CO2. This is the magic of Na or Avogadro constant, that when you multiply it, the mass number or the atomic mass unit which is described at an atomic level, it converts it to a practical level directly without changing the coefficients of the equation. जो चीज पहले एक एटम के टर्म से बोल रहे थे वो अब हम एक मोल के टर्म से बोल रहे हैं, बट द वेट इज वेरी मच easy to tell. 12 grams is very easy to visualize. 32 grams of oxygen is very easy to understand कि 32 ग्राम of oxygen कितना होता है. It's very hard to say कि 6.022 into 10 raised to 23 molecules of oxygen. It is far easy to say 1 mole of oxygen, and it is easy to understand that it means 32 grams of oxygen and gives 1 mole of carbon dioxide, which is 44 grams. 12 gram of carbon, it directly tells you what is the mass number, which is A of the original carbon atom. Same thing with all of these numbers, it directly tells you A, which is the mass number of that particular molecule. And students, this is the real reason we have mole concept, to convert mass number or atomic mass unit to grams very easily. बच्चों जिसको समझ में नहीं आया एक बार और देख लो, यहाँ तक आ जाएगा समझ में. सिंपल गेम है. जो एटॉमिक मास नंबर है या एटॉमिक मास यूनिट है उसको हमें ग्राम में कन्वर्ट करने के लिए एक कॉमन नंबर से मल्टीप्लाई करना पड़ता है, विच इज Na और एवोगाड्रो कांस्टेंट. किसी भी एलिमेंट के एटॉमिक मास यूनिट से उसको मल्टीप्लाई करो, वो सीधा उसको ग्राम में कन्वर्ट कर देगा. One thing to remember is that the atomic mass unit is not very simple. Other subatomic particles अगर उसका वेट होता है तो वो इसमें इग्नोर्ड है. इसमें सिर्फ न्यूट्रॉन एंड प्रोटॉन से ही हम बात कर रहे हैं. सेम थिंग गोज एट द mass at molar level as well. Just to be clear, 1 mole of oxygen atoms is 16 grams. 1 mole of oxygen molecules is 32 grams. This is called atomic molar mass. This is called molecular molar mass. Let's be very clear about it. It can be anything. एक atom का भी हो सकता है. There are few elements which will exist in multiple atoms या कुछ molecules हैं. So you will have to always understand. You will always have to question yourself कि ये atom का मोलर मास की बात हो रही है या मॉलिक्यूल के मॉलिक्यूलर मोलर मास की बात हो रही है. ये चीज जो है आगे के न्यूमेरिकल्स में हमें ध्यान रखना होगा. सो गाइस, लेट्स मूव ऑन टू द न्यूमेरिकल सेक्शन. तो पहला क्वेश्चन है, हाउ मेनी मॉलिक्यूल्स ऑफ CO2 आर देयर इन 88 grams of CO2? So the easiest way to solve this question is to convert 88 grams of CO2 into moles and moles. Let's say you want to calculate n, ये कितने moles है. Why? Because we know 1 mole of anything has 6.022 into 10 raised to 23 entities. So to calculate the number of moles of 88 gram CO2, first of all we have to determine what is the molar mass of CO2. So to calculate that, we know carbon ka it's 12 grams, one carbon, 1 mole of carbon. For oxygen, single oxygen atom, 1 mole of single oxygen atom is 16 grams. For CO2, there is O2 in that. So one molecule of oxygen, or you can say two atoms of oxygen, that will have total of 32 grams. Total will be 44 grams. Now calculating N is very simple. It's simply 88 divided by 44, that 2 moles, correct? And we simply multiply Na with 2, and that is the number of molecules in 88 grams of CO2. So 6.022 into 10 raised to 23 multiplied by 2 will be 12.022 into 10 raised to 23, or 1.2022 into 10 raised to 24. Either of these is the correct answer. Next question is even simpler one. Mass of one atom of the element A is 3.9854 into 10 raised to minus 23 grams. Correct? How many atoms are contained in 1 gram of element A? This is a very simple unitary method question. So let's say one atom is 3.9854 into 10 raised to minus 23 grams. Correct? So you can, now you have to get the value of 1 gram. So what you can do is you can simply bring this down as a denominator. So this will become 1 gram as 1 divided by 3.9854 into 10 raised to minus 23. This is the number of atoms in 1 gram of element A. If you solve it, the answer is 2.5092 into 10 raised to 22 atoms. Next question. A solution containing 10 mmol, मतलब millimole of CaCl2.2H2O is diluted to 1 liter. Calculate the number of grams of CaCl2.2H2O per ml of the final solution. Few things to notice here. M mole मतलब millimole मतलब 10 raised to minus 3 से multiply हो जाएगा ये, this 10. Second is CaCl2.2H2O. ये this is a complete compound. This entire thing is one compound. Now, if you dilute it to 1 liter, there is no visible impact on the 2H2O part. Nothing changes here. In fact, in the next line, it has directly asked calculate the number of grams of CaCl2.2H2O. मतलब CaCl2.2H2O को कुछ नहीं हुआ. You can very clearly assume that part. It remains as same. So calculate the number of grams. So first of all, the first thing we know is 10 millimoles, that is 10 into 10 raised to minus 3, 10 raised to minus 2 moles. This is the first thing we have figured out. इतने moles हैं CaCl2 का. Next is calculating the molar mass of CaCl2. So you can look this number up. For calcium it is 40. For chlorine it is 35.5, and if you double it, because there is Cl2, this will become 71. For H2O we know it is 18, and it is 2H2O, so it is 36. Total is 147 grams per mole. Correct? Now the first thing we should find out is number of grams. ये 10 millimoles का mass कितना है? That is something we should figure out. So mass of 10 mmol will be 147 into 10 raised to minus 2. तो ये हो गया 1.47 grams. Correct? लास्ट में वी हैव टू फिगर आउट number of grams per ml. And in 1 liter, how many ml is there? 1000 ml. So 1.47 gram is present in across 1000 ml. Hence 1 ml will have 1.47 divided by 1000, that is 1.47 into 10 raised to minus 3. The final unit is going to be gram per ml. So this is the correct answer. Next question, mass of one atom of X is 6.642 into 10 raised to minus 23 grams. What is its atomic mass? How many moles of X are contained in 40 kg of it? Guys, quickly solve करेंगे इसको. It's very simple. एक एटम का मास दिया है हमने को. We have to find the atomic mass. तो एक एटम के मास को एटॉमिक मास में कन्वर्ट करने के लिए you have to multiply it by Na. So 6.642 into 10 raised to minus 23 multiplied by 6.022 into 10 raised to 23. ये दोनों कैंसिल हो गए आपस में. Multiplying this and this will give you 40 grams. Simple. So 1 mole has 40 grams. This is for 1 mole. Now question is how many moles are contained in 40 kg of it. 40 kg is 40,000 grams. इसको 40 से डिवाइड कर दो. You are left with 1000 moles. Simple. Next question. Gypsum is a hydrate calcium sulfate. 1 gram sample contains 0.791 grams of CaSO4. How many moles of CaSO4 are there in sample? Next part is assuming that rest of the sample is water. How many moles of water are there in the sample? Show that the result is consistent with the formula CaSO4.2H2O. So basically इसमें there are two things to figure out. First is how many moles of CaSO4. Second is whether the complete compound honors this equation or not. So what we have to find out first is 0.791 gram में कितने मोल CaSO4 है. That is the simplest thing because there is no other dependency. So first of all let's figure out 1 mole of CaSO4 में का मास क्या होगा. So calcium is 40, sulfur is 32 guys, and oxygen एक एटम का 16 होता है, एक मॉलिक्यूल का 32 होता है. यू कैन से देयर आर 4 एटम्स, so this is total 64. So total is 136 grams per mole. सबसे पहला प्रॉब्लम तो वैसे ही सॉल्व हो गया. हाउ मेनी मोल्स? सो 0.791 ग्राम को अगर मोल में कन्वर्ट करना है तो 0.791 divided by 136. The total will be 5.816 into 10 raised to minus 3 moles. So this answer is in moles. Now let's look at the simple ratio. This is for every 1 mole of CaSO4 there are 2 moles of H2O, correct? So if there is 5.816 into 10 raised to minus 3 moles of CaSO4, water का होगा इसका into 2. So that will be roughly equal to 11.61 into 10 raised to minus 3. Let me write it clearly. 11.61 into 10 raised to minus 3 moles of water should be present. This is what we are supposed to prove. ये prove करना है हमें इस line से, assuming that rest of the sample is water, correct? So let's forget this number for now. Let's calculate it. So 1 gram में सिर्फ 0.791 ग्राम CaSO4 है. So rest is water. So 1 minus 0.791 209 0.209 gram of water is there. एक ग्राम एक मोल H2O का मास होता है 18. Now if we calculate the number of moles in 0.209 grams of H2O, that will be this will turn out to be 11.611 into 10 raised to minus 23 moles. So if you calculate it from the mass, you get 11.6, which is just double of 5.816. So it means the sample is correct and it honors the, and it is consistent with the formula CSO4.2H2O. So guys, that will be the end of this lecture. The next lecture will be on laws of chemical combination. Please subscribe to Chemistry Bytes and drop all your doubts in comments. Thanks guys. Thanks a lot.